Good morning, students. On continuation of synchronous motor, today we are going to cover in this class hunting of synchronous motors. This topic regarding to AC motors C18 EE Final 3 5th semester. Last class we have covered use of synchronous motors as a synchronous condenser and problems on synchronous condensers, how to generate reactive power to meet reactive power consumed by remaining induction motors in a industry under no load condition or small amount of the load. Our synchronous motors runs at over excitation, then we are going to generate reactive power which can helps to increase our total system, our main industry power factor. And based on this one, what are the existing inductive loads before synchronous condenser, what is its active power, reactive power and apparent power. Based on this one, we calculated few problems. Now let us, one phenomenon of synchronous motor is hunting. What do you mean by the hunting? Let us see. It is a very small topic, but it is a interesting topic. Please listen it. Today objectives, on completion of this period, you would be able to know what is hunting in synchronous motor, causes of hunting in synchronous motor and prevention of hunting. So, reasons for hunting and prevention methods of hunting we are going to learn, a very small topic. Let us see. What is hunting of synchronous motor? So, meaning, you can see, when the load applied to synchronous motor is suddenly increased or decreased, the rotor oscillates about its synchronous position with respect to the stator field. This action is called hunting. Here you can observe it. Our synchronous motor is constant speed motor. Now, if you are going to apply suddenly increased mechanical load on synchronous motor, our rotor and stator is magnetically coupled. At the same time, the stator magnetic axis, rotor magnetic axis are coupled and there is a small difference of load angle alpha. If suddenly load increased on rotor, rotor fallbacks some more angle increases. During this period, alpha increases. The current taken from the supply has to be increased to produce the torque such a way that to meet the load increased on the motor to maintain the constant speed. Okay, it is done these things. Now, if suddenly load is decreased, then what will happen? Once again, it has to reduce its current to reduce its torque to maintain the rotor to avoid the overshoot the stator poles. During this period, what will happen? Sudden changing of low mechanical load on rotor. Rotor will oscillates at its stator magnetic axis, overshoots and undershoots. These oscillations may create mechanical resonance. So, this type of the oscillation of a rotor, we can say it hunting. Okay. So, we will see in details. What is the meaning? When the load applied to the synchronous motor is suddenly increased or decreased, the rotor oscillates about its synchronous position with respect to the stator field. This action is called hunting. You can see here. So, this is the definition, at the same time total meaning of this one. Okay. Now, what are the causes of hunting? Causes of hunting is mainly due to the two factors. What we have seen, one factor is use of synchronous motor for driving varying loads. That means on motor, the mechanical load suddenly changes. For example, you take it a punch presses, a shear compressors and shear pumps, where punch, you can see it, punch suddenly impact on a load and stops. During the punching period, it will rather more current because it is require the impact. So, these varying loads may be causes to hunting. Not only this one, and if supply frequency is pulsating, as we know that the synchronous speed ns is equal 120 f by p. Now, p here, ns synchronous speed is equal to 120 f by p. Now, what is happening? The frequency changes, synchronous speed changes. But under normal, the synchronous speed and rotors of synchronize each other. Both are good friends running at one speed. If changes suddenly the frequency, so there may be try to move the rotating magnetic field in based on the frequency. But due to the a large inertia, rotor unable to cope up. So, there is a possible to change its alpha loading angle. This may create hunting. Okay. So, these are the causes. We have the all equations we have done. So, what we have seen here, so synchronous motor, let us see. The synchronous motor, first of all, basic things you remember. So, what we are going to learn it. Dear students, once again I am going to summarize it. It is giving the some basics. You remember what we have seen in previous classes. As we know that, so you already drawn curves, and this is a load angle. Here we are taken as a power, or you can say it is a T torque. T is equal P by W. same power and torque are the in y axis, and whereas x axis is the load angle theta or alpha, you can say the alpha. Now initially the load, the alpha initially, so both stator rotating magnetic field, that is equal to this magnetic field, and rotor magnetic field small angle, that is alpha. To meet the losses, that is a constant losses, friction and windage losses, small amount of the copper losses, and iron and friction losses we have seen. Now in this case, stator rotating magnetic field and rotor magnetic field axes are coupled each other, magnetically coupled, and runs at the synchronous speed. Let us assume if load on the motor, if load is increased further on the rotor, then what will happen? Rotor further increases its alpha. Instead of this one, we are going to increase the alpha 1. Further increases, then alpha 2 increases. So based on this one, what is the happening? If alpha, instead of alpha to alpha 1, it has draw the supply current, correspondingly the current, armature current, to meet the increased load and to develop the torque, which is required the torque to maintain the constant speed, that is equal ns is equal to 120 F by P. Okay. Now due to the increased load on the motor, it draws the extra current to produce the torque. That means if alpha increases and torque also increased. So you draw it, the curve. So here goes on increasing this one. This is a torque. Is a stable operation up to the maximum, you can see it. Up to the maximum, it is the 90 degrees. That means rotor field axis and stator field axis alpha is 90 degrees. We have seen the vector diagrams also, we have seen. That means here once again remember, this is equal to voltage reference and is equal to EB, and but due to the small losses, EB is this direction at angle of alpha. A resultant of these two are, we are going to get the ER, resultant voltage, back EMF, vector sum of EB and terminal voltage is going to get the ER, and this current is a lagging IA, armature current. Here is the phi, this is a theta, this is a alpha. Vector diagram you have seen. So either of cases you can observe that if load increases, alpha increases, then correspondingly current increases. To meet the load on the motor, then the torque also, current increases, torque increases. So what is the formula? So we know that the torque is equal to T is equal to P by omega, angular velocity. The power is equal to, we know that what is the power? So power generated in mechanical power generated in synchronous motor, when we are assumed that resistance is neglected, then we are going to get that. So terminal voltage and resultant voltage ER sine alpha by X A. Here the voltage and resultant voltage and XA, let us assume it constant, then P directly proportional or T directly proportional to, you can see here from sin alpha, that is equal to, here T directly proportional to sin alpha. So this is the torque equation, and same torque and these are the same direction. If you draw this one, so we are going to the, this is the power equation. So both are at maximum at 90 degrees. That means if alpha changes, torque changes. If torque changes, power taken by the supply also changes. Both power and torque sinusoidally varies with power angle alpha. The machine gradually loaded up to P maximum, P max, maximum power, that is equal, so V into ER into sin alpha by XS. If the field current need to be increased, if the machine loss synchronism, if further increases above this one, alpha is equal to greater than 90 degrees, it tried to whatever the axis of the rotor axis and magnetic field, rotating magnetic field axis and rotor axis, it will collapse. The rotor will try to come to the standstill position, that's magnetic coupling breaks. During this period, while it is going out of our synchronism, so then we need to increase the excitation to cope up to the coupling. Now, so based on this our mathematical calculations analysis, we can conclude that, so everything is in mathematical, we are not saying simple. So your angle changes, torque changes, the power changes, and correspondingly current changes, and correspondingly speed, how the speed has to maintain the constant if even alpha increases gradually up to some extent. After that automatically we cannot handle that thing if load increases further. Then we conclude that here, so what happened? So hunting may be here when a synchronous machine is used to driving a varying load, when a condition known as hunting is produced. Varying load means suddenly increases load and suddenly decreases load on the machine. During this business, the current changes. This current try to produce large amount of the torque as well as a reduced torque. It leads to oscillation of rotor at its stator magnetic field axis. These oscillations of rotor is unadvisable. We can say this is the mechanical vibrations in the motor. The hunting may also caused if supply frequency is also pulsating in nature itself, because if our motor is run, electrical supply is run from any MG set, motor generator set, if motor, a diesel motor, if changes its RPM, then automatically frequency changes. The frequency, due to the change in frequency, our synchronous motor also change its speed, that is also produce hunting in our synchronous motor. So synchronous motors hunting may be reasons: one, the varying the load on synchronous motor, and the supply frequency itself variation. So these are the things to production of hunting. Okay, from this one, so we are concluded before going to analysis. So when synchronous motor loaded, such as punch presses, shear compressors and pumps where sudden load at the moment, its rotor falls back in phase by angle alpha. As the load is progressively increased, this load angle also increases so as to produce more torque for coping with the increased load, as we see. If now there is sudden decrease in the motor load, the motor is immediately pulled back to a new value of a alpha corresponding to the new load. But in this process, what happens? The rotor overshoots and hence is again pulled back, overshoots, undershoots. In this way, the rotor starts oscillating like a pendulum about its new position of equilibrium corresponding to the new load. If the time period of these oscillations happens to be equal to the natural time period of the machine, then machine may be resonance set up inside the machine. What do you mean with the resonance? Already you have seen in physics. The amplitude of these oscillations of rotor at its magnetic axis is built up to a large value and may eventually become so great so as to throw the machine out of its synchronism. Then motor will stop. So, motor and stator coupling out of the synchronism. What to do? To stop the building up of these oscillations, the big oscillations, the dampers or damper grids are employed in pole shoes, just like is induction motor bars, squirrel cage rotor. The dampers consist of a short circuited copper bars embedded in the faces of field poles of the motor. Then the oscillatory motion of the rotor sets up eddy currents in the dampers due to the Faraday's laws of electromagnetic induction and induces its eddy current which flows in such a way as to suppress these oscillations as per our Lenz's law. So, here, but what happened? This induced currents, eddy currents, try to oppose its cause of its production. What is the causes? Here, the oscillations. Why the oscillations may be occur due to the varying the load. So, this can be avoided, this can be suppressed by inducing the eddy currents in damper windings. But it should be clearly understand that dampers do not completely prevent the hunting because their operation depends upon the presence of some oscillatory motion only. Whenever the oscillation motions, when suddenly increased load, suddenly decreased load, there is an oscillation of rotor at its magnetic axis. At that condition, as per the Faraday's laws of electromagnetic induction, there is a relative motion between the stator field and the rotor field. Suddenly, then it induces the eddy currents in the rotor. At that condition, whatever the induced eddy current, try to oppose these oscillations. But there is no oscillation motion, the dampers are simply copper conductors. Okay? And however, you know that they serve the additional purposes of making synchronous motor as a self-starting motor. Here dampers can be used for one is preventing oscillations, that is a hunting. At the same time, it works as a induction motor startingly as in our synchronous motor. Starting purpose and preventing hunting purpose, we are going to place damper copper grids are copper winding on pole shoe of rotor terminals. These are the idea. So this is a you can see in details. Now students, this is very easy to understand. So everything should be in mathematical way. So you can see in clearly. The angle alpha goes on increasing as the load increases. So what is the load? You can observe this is a laboratory, you are going to add the spring load on rotor. Here the load is gradually you are increasing the speed, but in case of some applications, shearing compressors and sudden punches, at least you can take your notebook, and there is a pin punch is required. Suddenly you require the pinching impact and fraction of seconds. After that release, no load on the motor. Suddenly high load, no load, high load, no load. During this period, when the high load is on the motor, obviously draw the more current. The more current, more torque, and more torque, rotor will overshoot, and there is no load, undershoot, overshoot, undershoot. During this period, so we are going to adapt our preventive methods. Now, the correspondingly it produces extra torque by drawing extra current from supply to meet the enhanced load for maintaining the constant speed, because our aim is to run the motor at constant speed. For example, in case of the paper mills and steel mills. As you know that equations, all equations you know, armature current for phase is equal to Ia is equal to ER by ZS, the armature current. And what is the ER? The resultant EMF is equal to under square root of V square plus EB whole square minus 2 into V into EB into cos alpha. Here the ER depend upon the alpha load angle. Then ER alpha changes, ER changes, armature current changes, and armature current changes, automatically the power changes. That power is equal torque directly proportional to sin alpha. Now vector diagram, as you know that. So once the alpha varying from 0 to maximum 90 degrees, then EB changes correspondingly, ER changes correspondingly, current also it changes from so leading back magnitude as well as the angle changes with respect to the supply voltage. So well known, you see this one already you have seen, load angle versus and torque. Here what will happen if alpha changes, load on the motor changes, torque also changing. Further increase the torque, further increase up to the max of 90 degrees. If further increased on the load on rotor, then automatically go on increasing the torque. At one stage it braked the coupling between the stator axis and rotor axis, the rotor will comes to standstill position. So this is a already we discussed. Everything is mathematical proof. Now when the synchronous motor is loaded, what is happened inside? You can see the how rotating magnetic field and rotor magnetic field coupled each other. In first case you can see both are in the same axis. When due to the small the losses to meet, so it is a small alpha is a very less. If what will happen, if load on the motor is increases, the rotor falls back. During this period you can see it is a how the here the stator magnetic field and rotor magnetic field is a some shearing takes place. When the motor is loaded, its rotor falls back in phase by the load angle alpha. Due to increased alpha, the torque produced also increases, because T is directly proportional to sin alpha. If now load on the motor decreases suddenly increase now suddenly decreases, just like punch machine. Alpha also changes corresponding to the new load. It has to change. Then what has happened? Here load increases, suddenly decreases. Then alpha changes from large value to small value to meet constant speed. But in this process, the rotor overshoots because due to the inertia, you can observe the size of our synchronous motors. Due to the inertia, the rotor, so whatever the load, you can observe it. Suddenly loaded any motor, or for you take the for example, you take the some two-wheeler. So you and yourself, you are going to carry some 50 kgs of weight on your two-wheeler. When you are going to the upgrade on the road, your weight and your own weight and your some things, the 50 kgs of your rice weight. So load on your two-wheeler, that may be bike. So try to draw the more fuel to cope up the speed. Now what will happen? Suddenly your rice bag is fallen. Then what happened? So automatically the load on your two-wheeler decreases. It try to move very fast comparing to the previous case. So there is a jerk from when 50 kg bag on your vehicle suddenly removed, then independent of your accelerator, the vehicle will give a jerk, the movement. So this movement is known as, in our case we are saying this is a hunting oscillator. So here you can see our synchronous motor. It's a costly machine and it has a large sizes. The rotor, due to this one, sudden increases, sudden decreases, increases, sudden decreases. So what will happen? There is a alpha changes. But in this process, the rotor overshoots. Due to this, rotor starts oscillating like a pendulum. What do you mean pendulum? So have we seen in physics laboratory in first year level about its new equilibrium? You can see this pendulum. The pendulum is moving either direction. So before going to the stable at center, it overshoots and undershoots, overshoot, undershoots. So after whatever the energy in the pendulum goes 0, then it will straight. Similar to this, the pendulum, our rotor also overshoots and undershoots, overshoots and undershoots, and comes to at near to the stator magnetic axis. Like this, motor is hunting for the right position when the load on the motor changes, whether it is increased or decreased. This is also called a phase swinging. We can say hunting, phase swinging, or we can say surging, surges. If this frequency of oscillations is equal to the natural frequency, then our mechanical resonance is set off. And the amplitude of the swing of these rotor poles relative to the poles of rotating magnetic field of stator becomes so great that the machine thrown out of synchronism. Hunting is objectionable characteristics of synchronous motor, like as it produces a severe mechanical stresses inside the machine. It vibrates machine, mechanical damage to the machine. At the same time, a large variation in current and power drawn by the motor, which is connected to the NPDCL supply peoples, swinging on the distribution lines also. You can observe nearby your house when there is a near the welding shop. While doing the welding work nearby your house, the load on your house may be varies. Your light may be glow bright and dim based on the performance of welding machine works nearby workshop. That means when the load on the welding machine increases, it draws some more current at a time. During this period, you can observe your lights may be dim if the transformer is not capable to meet these loads. Similarly, here also what will happen? A large variation in current and power drawn by the motor on our supply. Hence, we require to prevent hunting. Now we have seen what do you mean the hunting and what are the causes of hunting and how we are going to hunting, we are going to learn it. So main prevention of hunting. Hunting is prevented by providing a damper winding, also known as a squirrel cage winding. What do you mean the squirrel cage? Squirrel means this is the one type of the small animal which is placed in a cage. So our rotor looks like a squirrel cage. So its name is the squirrel cage rotor induction motor. You can see here armature winding or damper grids. So as you know that here the rotor. So we are going to this is a poles, number of poles. The pole shoe, you can see here this is a pole shoe. Here we are going to provide the copper wires placed and shorted at both ends, soldered at both ends. Similarly on pole shoe. This is known as the damper grids or damper bars. You can see this is a squirrel cage rotor. Skewed some angle. Here what will happen? In this slats there is an insertion of some copper bars placed this one and shorted, soldered at this one, soldered at that side. So what will happen? Whatever the EMF induced in the rotor bars circulate in a closed path. It induces its own current. Now here you can see clarity. The pole shoe, this is the field winding, and whereas in this case you can see here copper strips are placed and soldered here at both ends. Now you can see whatever the induced current flows is just like closed path. Coil, it acts as a coil. You can see here the rotor bars, pole core. On this one, the pole shoe, there is a copper strips inserted. The damper winding consists of copper bars embedded in faces of the field poles and short circuited at both ends by means of end rings as shown in the figure here. So you can see it's short circuited, all rings are short this either side. Then what will happen? It acts as a closed path, all bars. Circulating current flows on this one. You can see the size of the rotors and physically how they are providing the air bars. Okay, this size of the rotor, once the load increases, what will happen? It will move this direction, will move this direction. If load increases, falls back. If load suddenly decreases, this overshoots. This is the oscillation of this rotor, big size this one. So it may creates the mechanical vibrations in the motor. That is unavoidable. This is avoidable. Otherwise, it's a large vibrations takes place. That purpose we are going to provide the damper winding. Okay, this is the small topic. Now, damper winding. So when the motor is operating at exactly synchronous speed, rotor speed and rotating magnetic field speed are equally synchronized at the same speed, what will happen? So there is no relative motion between the magnetic field and rotor conductors. There is no EMF induced in the damper windings when both are in same speed. There is no relative motion between the rotor and stator rotating field. So no current is induced in these damper windings. But when hunting takes place, when overshoots and undershoots instantly, there is a relative motion exists, and therefore eddy currents are set up in the winding. These currents in a nature opposite is cause of its production as per our Lenz's law. What are the reasons? Vibrations. That vibration can be nullified itself with the help of its kid, that is the eddy currents, which flows in such a way to suppress the or damps out the oscillations. The dampers cannot prevent hunting completely 100% because this this eddy currents will generate whenever there is a oscillations. So to produce eddy currents we require the oscillations only. So we cannot depend on the 100% because their operation depends upon presence of oscillating motions. The damper winding also serve to make the synchronous motor self-starting, not only for hunting, prevent the hunting. These damper windings also used to starting the synchronous motor, because synchronous motor is not a self-starting motor. Even there is a three-phase supply is given to the stator and DC supply given to the rotor. So we require the starting of synchronous motor initially. That purpose we require the different methods. Here our damper methods, damper windings, they are used to start the motor as an induction motor initially, as well as it helps whenever the vibration takes place in the motor. So these are the some small topic regarding to synchronous motor hunting. So we have discussed about what is hunting in synchronous motor, causes of hunting in synchronous motor, and prevention of hunting in synchronous motor we have seen. Dear students, I think you have idea about this, what do you mean with the hunting in our synchronous motors. Thank you.